I don't think that there's too much hype about AI. I believe this is the most important technology, let's say, revolution that I've seen in my increasingly long career.
And they take a picture of their screen and they send it to AI. Now, very important to make sure that they have the tools.
Network. More than that, we need packet level truth to identify what's been happening on the network. That's where the deep network observability comes into the picture, where it can.
Now, as mentioned before, and possibly paraphrasing it to one of my colleagues, it says the network doesn't lie. You need to start with good data, good telemetry. You get that.
Well, I'm sure everybody on this call has heard the very famous statement, PCAP, where it didn't happen. Again, we've referred to.
I would like to thank all the panelists who joined us today. Today's discussion wasn't just about AI, it was about the trust. We explored the operational challenges AI is creating. Hello everyone and welcome to today's session, The Human Voice in the Age of AI. I'm Shruti, Digital Marketing Manager at Aviz Networks, and I'll be moderating today's conversation. Thanks for tuning in. AI is reshaping how enterprises build, operate, and secure the infrastructure. But far less attention goes to the operational side of that shift. How teams actually monitor, investigate, and respond once AI is running in the production. So that's the gap that this panel is here to discuss. Today, we'll move through 5 perspectives. We'll start with the analyst view of where the market is heading, then hear the day-to-day operational reality from a customer's point of view. From there, we'll go to deep dive into 3 technical pillars: deep network observability, cyber exposure management, and definitive packet evidence, before closing with how AI Ops brings it all together. Let me introduce today's panelists before we dive in. For Analyst view, we have Krupeka. He's the co-founder of 650 Group, a leading marketing intelligence research firm covering communications, data center, and cloud markets. With over 20 years of financial and industrial analysis experience, he tracks how enterprises are investing in networking, security, and AI infrastructure. As these markets evolve, Chris brings a data-driven industry-wide view of where AI adoption is heading across enterprise IT. We also have Daniel Krupeka, who's going to be giving the customer POV. He's a principal solution architect and strategic technical advisor at Insight. With more than 30 years of experience helping enterprises design and run their network, security, and data center environments, he's also a longtime Cisco certified system instructor who spends his days in the operational reality of modern hybrid environments, where AI is making it harder to connect the dots across tools and build trusted visibility for NetOps and SecOps teams. We also have Vincent Vermelin, leads technical strategy and program development at Armis, which is under ServiceNow, where he bridges high-level strategy with hands-on technical execution for a new product initiatives. His work spans building out AI-enabled security platforms, operationalizing key vendor integrations, and driving strategic partnerships across the ecosystem. We also have Michael Morris, who leads business development and technology alliances at Endace, bringing over 25 years of experience across software and hardware solutions for network and infrastructure management and security. He's a recognized thought leader in network monitoring, security, and packet capture, helping organizations get definitive evidence when incident occurs. Now we have Ram, who's a technical marketing manager at Aviz Networks, where he works hands-on SONiC, open networking architectures, and network observability. He helps enterprises evaluate, pilot, and de-risk SONiC deployments through practical guidance, live demos, and real-world use cases. With that, let's get started. So Chris, you spent a great deal of time speaking with enterprise IT leaders, cloud providers, and networking vendors. AI is clearly transforming businesses, but it's also changing how organizations build, operate, and secure their infrastructure. So we would love to start with your perspective on what you're seeing across the market. I guess my first question is going to be, AI is delivering tremendous business value, but every new technology which gets introduced, it introduces new risks. As enterprise accelerate AI adoption, what operational and security challenges do you think organizations are underestimating today?
We expect to see large language models and other types of models on endpoints and in data centers and in the cloud. And what that means is that the engines of AI are going to be essentially located everywhere. In addition to that, we're likely to see open models exist in all those places, as well as closed models in the cloud. And again, it means that these AI engines are going to be located in many different places. Also, we'll see that agents, the software systems that access these models, are very likely to explode. They already are this year. And then the rules that agents use are going to be different than the rules that people experience with grabbing information. So the risks and operational things that are happening this year are only the beginning. So for instance, grabbing information as a user is easy. You use a web browser, you go get it. But grabbing information, if you are using agents, presents actually quite significant risk to organizations. Terms of service violations when visiting public sites, 402 payments, these are crypto payments you will likely be paying at the end of this year and beyond to grab information, presents like a money risk. And then also corporate risk in a general sense, expanding with the use of agents and models, because the information that a company has can be sent to the wrong place and used against the company. So operationally, it's the use of these models and agents is changing the way companies work, but also the risk that the companies endure or will endure is dramatically increasing with this new type of computing.
So to your point where you mentioned the risk that it brings, with the ease, we do see a lot of employees, they use public AI services, developers building AI-enabled applications, and infrastructure team modernizing their environment. Which of these do you believe is creating the biggest challenge for enterprise IT and security teams today?
Well, I mean, I think that the biggest and most obvious risk is when an employee uses a public model to get some of their work done and uploads, let's say, sensitive corporate intellectual property up to a cloud model. It is a point of speculation, but I do believe it could be true, is that this information essentially is used in the next revision of models that can show up. And what that means is the data that you could send up to a cloud model might end up being used to enable competitors to your own business. So imagine now you get your job done quickly because you're using a public model, and then next thing you know, your business is the business environment you have is more competitive than it was just a year ago. So I think it's a very significant risk from the standpoint of a business, but also consider that there also might be significant liability that comes from sending customer data up into public places. I think that's another very real risk, and it's quite different from the competitive landscape changes. But these are two very, very significant risks. And then the third one, I've mentioned it a little before, but when you have agentic systems going out and gathering information, it's very likely that they are, being asked to do things that are maybe naive and can see like terms of service violations when they visit, or might be incurring charges to go visit sites through the 402 payment system that is emerging at the end of this calendar year.
And do you think the industry is spending too much time talking about building AI and not enough time maybe talking about how to operate and govern AI once it's in production?
We think the AI industry, which is more or less just beginning, will reach trillions of dollars in the next handful of years. So no, I don't think that AI is being overhyped. I would argue that it is like the most important thing we've seen in computing, probably more important than the mobile surge that we saw around when the iPhone was launched, and then in the mid and late 90s, the internet boom. This is actually more important to know. I don't think that there's too much hype about AI. I believe this is the most important technology, let's say, revolution that I've seen in my my increasingly long career.
And if you were to advise a CIO planning for the next 3 to 5 years, what capabilities should they prioritize today to operate and secure AI with confidence?
Well, AI is a whole new computing stack, and it is sort of located everywhere, on the cloud, on endpoints, and in corporate data centers, to name some of the most obvious places. So this new stack is very complex because the information and the users and the agents are located essentially everywhere. Therefore, it's important to know what the applications are doing and what the network that's connecting all those agents and models are doing, and what's happening in the cloud. So in a sense, visibility across these different domains is critical. And I think you can safely say that one of the primary projects that IT divisions within large companies should be doing is pursuing the critical underpinning of building out an AI observability system.
Thank you, Chris. So let's move from analyst perspective to someone responsible for operating these environments every day. This isn't about a success story, it's about the operational reality of running modern enterprise networks while AI adoption continues to accelerate. So Daniel, my question to you would be, as AI adoption has increased across your organization, what has changed the most for your operations and security teams? What's become noticeably harder than it was just a few years back?
Yeah, thanks, Shruti. I think that from an AI adoption standpoint, I think Chris made a lot of good points about, so I'll answer the what's become harder, right? So one of the things that's become harder is making sure that we have the guardrails and controls in place. We don't want confidential data ending up on a public model or, being trained for something else. But on the other side of that, there needs to seek a balance. The people are people. They understand AI. They are adopting AI in everyday ways, and they're comfortable with using it. And it's being told not to use it is a risk for the organization. So that's things that we've seen as well, where you have some organizations where they're like, no, we just have a no policy or their policy is very strict. They're not going to use it. And when you have that situation, you have the worst case scenario, right? That's where the engineer is trying to choose something, and they have the AI model. They have the AI model right here. It's right on their mobile phone, right? And they take a picture of their screen and they send it to AI. Now, they wouldn't take a picture of their screen and post it to Reddit. They might know that that's probably not a good idea, right? That part, but posting it to and using it on a model of their phone, they feel very comfortable with doing that. They're like, it's kind of wrong, but we're in a situation, we have to solve a problem. So it's very important to make sure that they have the tools that can, that allow them to do their job and accomplish their job in the way that they want to do. But to also make sure that, there's some guardrails and controls around that. If anybody doesn't believe that people have not used their phone to take a picture and of their screen and send it up to AI to troubleshoot it, I'm here to tell you that give them some tools, right? Give them some tools. If you don't, that's where it's going.
I guess I totally agree with that. I've seen a lot of my friends do that. So yeah, I can totally understand.
People, right? People are people.
So I think my next question is going to be, when something goes wrong today, whether it's application performance, unusual network behavior, or a potential security incident, where do your team struggles the most? Is it finding the right data, connecting information across different tools, or simply knowing where to begin?
A big part of it's training good troubleshooters, right? In the SOC, in the NOC, being able to troubleshoot. And there are still some fundamental things that can be very tough, and that's defining the problem. It sounds like a really easy thing, but when you define the problem, you're specifically saying what the problem is, where it started, what exactly that problem is. You're validating that problem with data points. Yes, we saw this system go down, or we saw this unusual log activity, or we saw this connection come here where it's never really come there before. And being able to get that data to help fully define where the problem is and assess and troubleshoot the problem. That's one of the things where we've definitely looked at AI tools and use AI tools to be able to do that. to help us, and that reduces the engineer's cognitive load, right? They've got a lot of stuff going on. There's more information, right? There's not less information coming in. Nobody has that problem. There's more information, and a lot of times it's the wrong information, and they don't get the right information from the right parts of the system.
And right now we can see that there is almost a boom. Enterprises today have significant investments in monitoring, observability, and security platforms. So as your environment has expanded across data centers, cloud edge, IoT, OT, and AI-enabled applications, where do you see the biggest operational challenges? Is it collecting more telemetry or making sense of the telemetry that you already have?
Making sense of the telemetry we already have is huge. And there are certainly places where you need to connect it as networks and systems grow, interactions with businesses, cloud, hybrid models, all of these different things. And also with regulation, there's data residency requirements and these type of things. So it's not necessarily like I can just set up one collector and collect data from all over the world. That's not a realistic approach. So that's one of the things. I think the other thing is that multiple teams, we have specialized teams. They specialize in different things. Even though some tools, quote unquote, can do it all, I think the teams need the tools that they need to use to do their job, to be able to get the information as quickly as possible, accurately as possible, to solve the problems as quickly as possible.
And if AI is going to become a part of day-to-day operations, what would it need to demonstrate before you trust the recommendations?
Well, I think it needs to make sure it stays within the guardrails of your policy in the company, right? So, you should have some sort of a policy that says how this data is handled, how it's updated, where it goes. And I think that's a fundamental building block. If you have that foundation, then we have lots of ways to do it. But if you don't have that foundation, all your decisions are kind of built on a house of cards. But to ultimately springboard off of that, I think it's really about reducing the cognitive load of the people that are working on the systems to help them make better decisions, but also to help them be a more effective human in the loop, right? We strongly believe of human in the loop, and that's a very important thing. We'll let the robots do the work where they need to do it, but many times we need to have humans that can critically think, to be able to ask, is that true? Is this right? Is that, with the confidence to be able to challenge, any suggested conclusions from AI.
So that's an interesting point. It sounds like the challenge isn't collecting more telemetry, it's connecting the right telemetry to build a trusted operational picture. We have heard about the operational challenges of the organizations which organizations are facing. So Ram, let's talk about the network itself and why deep network observability has become such an important foundation for modern operations.
Thanks, Shruti. I think, before I start, I would like to talk about the fundamental challenge of, collecting the right telemetry. Because if you look into any modern enterprises, as how they grow, workloads are not like, static. It's like, more dynamic. And then, it is also important to have this visibility or the observability enabled at every place of your network. Because, considering the increase in the bring your own devices, adoption of hybrid and multi-cloud, and then, to remote and edge, and increase in IT/OT, cyber risk that what we are seeing day to day for all different kind of attacks that just happening over day by day. It is important to enable this deep network observability at every place, not leaving any blind spots on your network, right? And then the second point is that when we talk about telemetry, it is not like, we just collect telemetry from specific devices or like, from specific points, right? We need to collect these telemetry from each and every place of your network. And then, this telemetry has to give you the ground reality, that is the truth of the network. Because when people rely more on the logs that just comes from the the components that just sits on the network. More than that, we need packet level truth to identify what's been happening on the network. That's where the deep network observability comes into the picture, where it can tell you the packet level truth complementing the melt. With all these evidences, you can really understand what's been happening.
And so I think my next question is going to be organizations, they already have monitoring, security, and observability platforms in place. Yet when incident occurs, teams, they struggle to get a complete picture. What's missing from today's approach, and how does deep network observability help close that gap?
That's a good question, Shruti. So traditionally, what organizations do is that they highly dependent on the metric events, logs and traces that's been captured from different network components, right? Now, these metric events and logs and traces are mutable. Now, when do I say mutable? Because one of the things that attackers will do when they try to take controls of your devices, they either try to manipulate the logs, or they try to disable the logging, right? So that is where that's where we need to have the truth of the network, that is the packet level evidence, and that's going to be more important and tell you exactly what's been happening on your network, or what happened on the network.
Okay. And so for my next question, you often describe packets as ultimate source of truth.
Yeah.
Why is packet-derived telemetry becoming such an important foundation, not just for troubleshooting, but also for security and AI-driven operations?
So, as I mentioned earlier, typically people uses the logs, which they believe the ultimate truth of the network. But packet level evidence would actually complement the melt with the evidence that's been collected. Now, for instance, most of today modern enterprises attack just happens not only just capturing the devices which sits on the north south, it is also extended on the east west and to your remote or edge, right? So this packet level evidence will gives you the ground truth, assuming if an attacker take access of your control and they try to disable the logs, right? When the moment you capture the packets, you will able to understand what just really went, what kind of attacks, what kind of attack patterns that's just been happened. This helps organizations to identify the problem as much as possible, to help you to do certain root cause analysis, and then you can take this packet level evidences or store these packets into a packet recorder. I think Michael will talk more about it for any kind of compliance or any forensic things that you want to do it in the later part of your network.
And once packet-derived telemetry is combined with existing observability data, how does this change the way NetOps and SecOps team investigate incidents, identify root causes, and make better operational decisions?
Yes, that's a good question. Now, if you look into this NetOps and SecOps team, how they operate, in the enterprises first, these two are individual, I would say organizations or the teams that work together. But these teams will have their own type of telemetry that just receives in their monitoring tool. It could be a network monitoring tool, or it could be the security tools, right? So with the packet derived telemetry, what we can really bring together is that we can just bring all the network telemetry and the security incidents together, so that both the NetOps team and the SecOps team can work together to correlate these data, to identify what just been happened, or what's going to happen on the network, right? So that makes their operation more easier. For example, if an issue takes 2 hours of time, for the network team first to analyze and tell us what happened, and then the security teams then forward it, then work with them to identify what's been happening, right? So with this correlation, the mean time to resolution is certainly going to come down, to identify any incidents or any things that just happened on the network.
And I think my next question would be, how should organizations think about packet-derived telemetry as part of their broader observability strategy?
Yes. So when it comes to the packet-derived telemetry, I would say, like, this is the truth of the network, as I was mentioned earlier. It's not like, just generated just for the specific teams to solve some specific problems. It basically brings your network and the applications team together. For instance, the network derived telemetry, such as like, things that just happens on the network, for example, the CRC errors, or like, any kind of TCP resets or anything that just happened over the flow, that can be identified. At the same time, the packet derived telemetry, for the application team, it can basically, extract and give some kind of application level logs that can, tell the application team, like, what's just been happened on the network, because application team will purely dependent on the application logs that just comes from the, from their own native log systems, like, the Nginx logs or the Apache logs or the Kubernetes-based logs, right? So, this just gives you, like, the insights from the network perspective and then from the application perspective. So combining together, like, you'll get a holistic view of, like, what just happened on your network, not just only, just what just happened on the network, what just happened on the application, right? So typically in the enterprises, there is this ball game, blaming game happens, like, whenever there is a issue set, network team says it's an application and the application team says it's a network team. So, with this combined strategy of deriving the packet derived telemetry, so both the teams, in the same organization can utilize it, and then which helps them to, reduce their mean time to resolution to solve any challenges that either happens with network or with application.
So to your point, packet-derived telemetry helps enrich existing observability investments by adding the network perspective. But understanding traffic is only one part of the equation. Security team also needs to understand that those assets actually are the risk they introduce. Most organizations...
Sorry, go ahead.
Most organizations, they have strong monitoring for traditional IT assets such as servers, endpoints, and network infrastructure. The bigger challenge lies with unmanaged assets: IoT, OT, medical equipment, industrial systems, IP cameras, and other connected devices that often operate outside traditional monitoring and security controls. So Vincent, I think my question to you would be, as organizations modernize their environments and AI continues to expand the attack surface, these unmanaged assets are becoming increasingly attractive targets. Why are they creating such a significant visibility and security challenge for enterprises today?
Yeah, thank you very much. Can break it down in a couple of bullet points here. Number one, there's just so many more of them, right? If you think about how many devices are on your network now versus even 5 years ago, it's almost an exponential explosion of these types of devices. Number two, many of these devices are weaker by design, right? These IoT devices, IP cameras, OT devices, some of them may be quite old, some of them are not updated very much, and most of them are not managed even in a central way. So they don't have a patch Tuesday as you would find on an enterprise laptop or desktop. And last but not least, very often these devices are co-located in the sensitive environments. So think of a printer that may be accessed from an Oracle's middleware server that's spitting out reports. So by being able to compromise a weaker design, a weaker device right at the edge of the network, you now have direct access to the more critical assets within the network itself. And AI is only speeding this up, not only in the sense of it being used in the environment, but also being used against the environment itself.
When you say using it against the environment, like that's a really valid and good point. I think my next question would be, many of these devices, they communicate using specialized or industrial protocol and can't really run traditional security agents. How does cyber exposure management help organizations identify these assets, understand their behavior, and prioritize the risks that they introduce?
So within cyber exposure management, the first thing you need to understand is what is your exposure in the sense of which devices do I even have, and what can they do and what can they access. So there are many environments, especially in the OT operational technology side, as well as in the healthcare side, where doing some type of active scanning is not really conducive to the environment itself, as in you can break the devices doing so. So having passive discovery of those devices, listening to the network in particular, is one of the very effective and in certain cases the only way to identify these devices via their communication, via their patterns, via the behaviors overall. The other part that comes into it is that these types of devices also speak a different language. Very often also not understood by the IT side of the house. So you think of SIP protocols and DICOM and things like that. These are protocols often unencrypted, but also different from the ones that the IT workers are familiar with. So by understanding the devices themselves, now we can understand what the communication patterns are, and we can start understanding what the priority or even the importance or the business criticality of those devices are, which becomes very important when you start looking at, oh, here's an event I see inside the network packets, but which device is talking to which device? That's the context that the folks need in order to be able to react to those kinds of events.
And as Ram talked about building trusted network intelligence through deep network observability, once organizations have the network intelligence, how does adding asset context help security teams make faster and more informed decisions?
Sure. And that really just continues my previous point, is being able to see traffic flows and traffic streams on a network. And I come from a background of being kind of a bit weenie and understanding, packet protocols and Wireshark. Before that was Ethereal, and before that was even sniffers. Seeing those packets and understanding something bad is happening is great. But then understanding, what's the priority of that? Which device is sending that? What type of device is receiving that? What's the important and criticality of that device? Which ones do I prioritize if I see multiple events happening? All those are absolutely critical to an incident response. And understanding those contexts of what is critical, what information is, or what assets are involved will also play into the speed of response, and being able to understand, okay, these are the ones I need to prioritize on. I'm going to focus on this. I need to resolve this as quickly as possible because it's critical to my business. And Daniel mentioned this at the beginning, speed of resolution, right? MTTR, that is a really critical part of the security operation piece. Now, the other side of this becomes, what about proactive response? What about the proactive aspect of this? Network visibility and asset context give you a picture into things like shadow AI detection. Whereas today people are using AI to, run questions and upload it to a public cloud. It's kind of like the old days of Dropbox when it first came out. Everybody's like, hey, this is great. I can throw my files up here and share it with my partners, and I can work together with them. Yay. But then IT got a hold of it and goes, wait a second, what are you doing here? The same thing's happening with AI, right? If it's free, you're probably the product, meaning they're harvesting your data. Same thing with a lot of other services. The end goal here, and what companies really are trying to focus on, is creating and enforcing the guardrails around AI, whether it's AI being used as shadow AI, whether it's AI being used within their cloud, within their data centers, or even the AI that, as someone's mentioned, that's running on your phone or on your mobile device. We need to have that visibility, first of all. We need to then be able to build that framework to enforce and govern those types of AIs. And Armis being now part of ServiceNow, that's exactly what ServiceNow is working on with the AI control tower. So it all starts the network, but it all ends with governance and control.
So with Armis operating effortlessly across ID and OT environments, how are you keeping up with the pace of high-speed, large-scale networks today?
So that's always a fun one. Networks have increased their speeds significantly. And back in the day when I was working for a company designing switches and routers, 10 gig was like, wow, that's great. When it comes to visibility, however, it looks at also from an architectural perspective. Being able to pre-process high bandwidth links and traffic, and being able to understand and feed those into the collectors or the sensors that can then interpret those packets is a really important part of the overall solution. But also looking at east-west, north-south traffic, right? These high-speed links are often within data centers, and you need that visibility. And on top of that, you also need the visibility at the edges of the network so that you can capture that east-west type of traffic, even between laptops, maybe perhaps talking to each other via AI agents. So having both solutions is critical. Having the ability to look at high-speed traffic and being able to parse that out and feed it into the appropriate collecting systems is also a critical piece of it.
So are you building anything at the hardware level to keep up, like running directly on NVIDIA DPUs on the Aviz DNO fabric, already offload traffic optimization at the DPU level, right? So
Yep.
is there a world where one DPU handles the traffic engineering and a second runs the Armis collector, exposure management processing at line rate on the same infrastructure?
So that's definitely the case. Let me start with Armis is not a hardware company. So we are, a SaaS-based solution. We are a software-based solution, but we partner, right, with the hardware vendors, to do that. And one of our partnerships with NVIDIA is exactly that. Our collector can actually run on a Bluefield DPU. And that allows us to be at those edges of the data centers or edges of the networks where those are installed without having to implement any kind of additional hardware than that. So then if you put the two together, being able to take that traffic, split it out, filter it in which way you need it, and then feeding it into our collector, which is also running on a DPU, is in the exact use case where this can be applied.
So I guess my last question to you would be, has AI changed the importance of maintaining a complete and continuously updated inventory of every connected assets?
I would say that has exposed it. I think it always has been important. 30 years ago, I had to write my own tool sets to understand what is connected to my network, but it often stopped at here's the IP address and MAC address of the device. Now we need more information about the criticality of the asset, operating systems, vulnerabilities, et cetera, et cetera. And when you look at AI in general, a critical piece of AI is having good data to work with. Now, as mentioned before, and possibly paraphrasing it to one of my colleagues, it says, the network doesn't lie. You need to start with good data, good telemetry. You get that from the network. That is what is critical and essential for AI to be able to have good data to then start putting it into context, understand things like shadow AI, understand things like connections between devices and which devices are running AI and using AI, which ones are vulnerable and introducing risk, and then taking the complete picture of what is the risk to my business. And that all starts at the network layer and works its all the way up to the governance level as well.
So network telemetry tells us that something happened. And first of all, thanks, Vincent, for such good, valid points. And now coming to asset intelligence, like all of this tells us what was involved, but when a significant incident occurs, security teams still need definitive evidence to understand exactly what happened. So, Michael, I think my first question to you would be, as attackers increasingly use AI to automate phishing, malware, and lateral movement, why is definitive packet evidence becoming even more important during incident response and forensic investigations?
No, Shruti, thanks for a great question. And I'd start with saying I think every one of my fellow panelists here have commented how packet data is the ultimate truth. And I think that's really where it all ties together. Packet evidence is really the only way SOC analysts to get to the ultimate root cause and follow threat actors, whether they're AI driven or not, across the network. That lateral movement. Any tool in the system may identify an indicator at one point or another point, but being able to track them and follow their footsteps, just like a crime scene, you want to follow the flow of where the malicious actor went or where the thief went. Packet data can help you do that. And packet data is really the only way to know for sure of things like data exfiltration. When you have to report for compliance purposes or things like that, what was exfiltrated? Was it sensitive data? Having the evidence is key to be able to make some of those compliance standards reportings. I read an interesting article in Dark Reading, I think just over a year ago, where they discovered that a bunch of Chinese threat actor groups were gaining access to networks, controlling ACLs and TAC controls, and were actually staying within the network. They themselves were actually recording packet data to find further credentials, high-value systems, and other vulnerabilities on the network. So I'd pose the question to you, if threat actors are using packet data to infiltrate, wouldn't you as a defender want to be able to at least keep up with them, right? And be able to see what they're seeing so you can know where the other vulnerabilities are.
No, that's very true and to the point. So I think my next question would be, security platforms, they generate alerts and AI can help prioritize them, but neither always tells the complete story. What role does packet evidence play in validating incidents and understanding their true impact?
Well, I'm sure everybody on this call has heard the very famous statement, PCAP, or it didn't happen. Again, we've referred to packet evidence as being the ultimate forensics, but having it and being able to capture it and go back in time enables you to connect the dots of other things seen, right? So all those alerts in your SIEM, the alerts from your firewall, the alerts from your endpoints, being able to tie those things together and again, build the story of what the threat actor is doing and follow them through your infrastructure. And let's be honest, AI makes it much easier. Having that data in your AI engine makes your AI smarter as well, right? Because AI is only going to be as good as the data it has access to. And if you think about it of a bunch of pictures, if you give it a bunch of snapshots, AI can piece together a story. But if you give it a full video stream of everything that happened on your vacation, they'll be able to tell you a better story. I like to use the example of a banking environment. Would you be comfortable putting your money in a bank that only relied on the alarms, the teller drawers, the silent alarms, the tellers can trigger the alarms on the vault? Or would you really want your bank to have that video camera recording of everything going on? So when the authorities come in, right, the first thing they do is they want to see the videotape. They want to know how many robbers there were, were they tall, were they short, were they armed, how many bags of money did they take out? That's all the evidence and examples that you would get in having full packet evidence over just those little indicators, those alarms from the teller. Okay, yeah, they hit teller 1 and teller 3, but how much money was in those drawers, right? Maybe those were low volume drawers. So again, having that extra level of insights is a game changer for a SOC analyst.
So to your point, I think the line that you mentioned, that to get the full story, you need to have the evidence. I think my next question is going to be, beyond forensic investigations, where are organizations finding value in always-on packet capture, from threat hunting and compliance to improving overall security operations?
Yeah, no, that's a great question. I think a couple of key areas. We're seeing heavy use of packet data in more proactive threat hunting activities. We had an example. This is a while back. A customer was impacted by the SolarWinds breach. So when the CVE came out about compromised access points to systems that had SolarWinds software, they could go back in time and look at all the traffic going in and out of those systems to understand, where was that data flowing? What IPs was it going to? What types of traffic was it? Was it normal SolarWinds communication traffic, or was there large volumes of tunnel DNS that may have been exfiltrating data, right? Having those types of understanding of what was happening on the network, again, can be the difference between really knowing how far and wide it was or being kind of lulled into a false sense of security. And you mentioned compliance. I think that's another one, right? All of us are very aware of around the world, different between DORA, GDPR, M2131, or the newly updated M26-14. All of them are giving companies and organizations, especially critical infrastructure, guidance in how much log data, how much network data is needed to go back in time and look at. M2131, which has now been updated with the 2614, they've recommended 72 hours of packet capture for government agencies. Well, it's a balancing act, right, for organizations to how much data they need, whether it be log data, whether it be network data, to really be confident to go back and investigate. And it's a business decision for every organization based on the criticality of their data, the sensitivity, and for many financial organizations, healthcare, nation states, they just can't leave anything to chance. And so I think that's where having the packet data can be critical for their organization's security and their customer security.
That's really a valid point. And I think my next question to you is going to be, as organizations increasingly adopt AI-assisted security operations, does trusted packet evidence become even more important in validating AI-generated conclusions?
Yeah, no, short answer to that one is absolutely. Packet data is crucial for that. And for a couple different reasons. Leveraging AI engines to look through packet data and find those other indicators in the kill chain of a breach can be a game changer, right? You may see the initial compromise of a system, whether it be through your endpoint or anything, but seeing that lateral movement, seeing other steps in the kill chain. Many malware today has multiple steps, multiple vectors that they're doing. Dwell times are going down, but that's because AI is helping to find things quicker. And I think, again, having that packet evidence is key because of, Ram mentioned earlier, logs, for example, are a common target for wipers and obfuscation. And so if you lose chunks of data, you become that much more blind. Whereas if you have that full record, the other thing AI can do is recursively get more intelligent. I mean, all of us on this call, I'm sure, have used a chatbot, started with a basic prompt query about something we're interested in. But once it comes back with some initial data, think about asking and leveraging AI to go deeper, right? Look for that next level of stuff. And this is where packet data can really elevate the experience in an industry where we're grossly short of expertise. Having AI, leveraging the information that AI can get from both logs and packet data can really elevate a junior analyst to be much more advanced in their investigation process, because they can be enabled with a whole bunch of information, and then they kind of become almost tier 2, tier 3 to start validating. I think it was Daniel mentioned, digging into making them smarter and asking more intelligent questions. If they got a third of the problem started and a bunch of assumptions and proposed things to look at, they're already farther down that path to accelerating that mean time to repair that I know Vincent was talking about as well.
Yeah, I guess the best example that I believe that you shared about security cameras, that's going to stay with me. That really does provide a good conclusion and to understand why exactly packet capture evidence is important. So yeah, now moving on to now, throughout today's discussion, we have explored all these three essential layers: trusted network telemetry, asset intelligence, and definitive packet evidence. The question now is how organizations bring all of this together to simplify operations and make faster, more informed decisions. That's where AI Ops comes in. AI is rapidly changing operations, but identifying a problem is only half the journey. Enterprise organizations also need governance, change control, and confidence before taking action. Let's talk about what responsible AI ops looks like. So Ram, coming back to you, we have discussed trusted telemetry, asset intelligence, and packet evidence. What role does AI ops play in bringing these together and turning them into actionable operational intelligence?
Thank you, Shruti. I think till now what we have discussed and outlined is understanding the importance of the deep network observability, and I think the panelists talked on various examples of deriving the packet level insights, the asset intelligence and the importance of the asset intelligence, and then having definitive packet evidence. Right now, what we have done is that we do have this foundation which is having the right telemetry, along with the melt and with the packet level telemetry. Right now, the real challenge what comes into the organizations is that when we have this right telemetry, but this right telemetry is also given to the tools in silos, because we do have tools that's been used by different teams, For example, the NetOps, the work with the NPM team, the DevOps will work with the APM and kind of SIMs, and then the SecOps works with the security teams, right? Now, if you want to, bring everyone together, with the help of AI, what you need to do is that you need to create an AI layer on top of all these three operators, where everyone works on the silos, right? So, having an AI layer, on top of all these tools, collecting data from all these tools, correlating it with the help of AI, LLMs, with the different sets of model, helps organizations to make it more of an AI operation data center or AI operation NOC center, I would say, right? Instead of like assuming if there is a problem, if there is an application slowness identified, now every team's connected on the war room, look into the logs and tells us where is the problem is, it takes longer time to solve the problem. Instead, if you have an AI operation tool which can collect all these logs, correlate it, and then give you the answer in maybe in a fraction of seconds, in a fraction of minutes, that's what AI operations is going to be.
And everyone is talking about AI agents that can automate network operations. But in enterprise environments, speed isn't the only priority. Governance is equally important. How do you balance AI-driven automation with operational control and change management?
Yes, that's right. Because when we think about AI as an example of the AI operations, right? Now, when you build agents to perform specific activities on the things that what it identifies, right? Sometimes it can be the LLMs can give you the wrong data or perform something which the network operator didn't want to do, right? So that's where you need to put up the process when you want to build something using the AI agents. So that is where you need to connect your AI ops tool to an ITSM tool where you need to follow the process how the human do. For example, whenever an AI ops tool identifies an incident, then you use your agents to create a ticket create a process, and then just goes to the specific individual who can look into the steps and then approve it. Then the AI agents can go and execute in any of the devices, right? So you need to form a process to perform any specific activities using the agents. So that's where you can implement compliance, and also it helps you to protect any things any kind of things that can go wrong, right? So that is where you need to have that process just to make sure that you're also more compliant.
So being compliant is always good and great. Totally hear you on that. Many vendors, they are introducing AI assistants into their platforms. From Aviz's perspective, what makes an AI-powered operations platform generally useful for network and security teams?
Yes, I think the very first point that what I would like to say from the Aviz perspective is that the network co-pilot, which is basically a private AI assistant, where it uses an LLM and then the own model that what Aviz has been built, that you can just simply deploy on your data center or even in an air-gapped environment where your data just keeps only on your network and then it doesn't leave. While we do this, we also give an option for the customers to connect to the public LLMs if they want, or they can connect to their own LLMs where they have enriched data sets. So this is where we'll be more realistic. We are not tied up to a single vendor. We are pretty much vendor agnostic. We even connect to a legacy systems that that's been built 10 years back, and then take the the right telemetry, look into it, and then tell us what's been happening.
So Ram, I think my last question to you is gonna be, do you think the conversation is shifting from which AI model should I use to can I trust the data feeding my AI?
No, I don't think so, because which AI model should I use is absolutely dependent on the customer, that how they want to execute and then how they want to use this AI. But can I trust the data feeding my AI? In my honest opinion today, I would suggest that any organizations can send this data to their private LLM, which just sits only on your network. But if something just goes into the public LLM, And yes, of course, there are policies and other things where the public LLMs claims that the data is still secured and then just keep it here. But in my honest opinion, I don't trust that. And having data just in my network is going to be the safest option in my opinion.
So, I would like to thank all the panelists who joined us today. Today's discussion wasn't just about AI, it was about the trust. We explored the operational challenges AI is creating, the importance of trusted network telemetry, understanding every connected asset, and having definitive packet evidence when incident occurs. Ultimately, AIOps isn't about replacing people, it's about bringing trusted intelligence together so operations and security teams can make faster, better informed decisions with confidence. Again, I would like to thank all of the panelists for taking out the time to attend this panel discussion. Thank you. Thank you, everyone.